Okay, so let's start. I would like to call my production colleagues here. Let me introduce them to you. We have David Costa, System Analyst and Seeq Administrator, Pietro Letizia from the Mantova Central, and Seeq User, Michele Pinzetta, Performance Operation Data Manager. Thank you for being here. So good afternoon, everyone. I would like to thank all speakers for their speeches. You're very well prepared. Thank you, Matika, for welcoming us here. We would like to start with a few words about our company. So basically, EP Produzione is an Italian electricity generation company belonging to the Czech energy group EPH, with a thermoelectric power plants of a capacity of about 4.4 gigawatts. Our plants are high performance and efficient plants managed to the highest standards in environmental safety and reliability. All plants obtained the EMAS registration. It's basically an environmental certification for health and safety. Our company really cares about safety, environment, and health. Our motto is take care, which means being careful at workplace, to our colleagues, to our partners, to our clients, basically protecting our environment, starting from our work environment and giving importance to our health and safety, basically. These are our company standards when it comes to safety, environment, and health. So just to give you a few key numbers from 2022, there are around 540 people in our company. As Jessica said this morning, many people are older than 50, so that's a pretty appropriate number. We have a net energy production of 16.8 terawatt hour, covering approximately 6.2 million families, therefore 4.4 gigawatts of generation capacity with 6 power plants and 3 headquarters in Rome, Milan, and Terni, with plants in the north, Tavazzano, Montanazzo, Fiumesanto, Ostiglia, Livorno, Trapani, and Scandale. Now, we are continuously investing in improvement processes for our plants. We are currently building 2 new power plants, one in Tavazzano and Montanazzo and one in Ostiglia, using the latest quality, performance, and low emission standards. In Fiumesanto, we are planning a multi-technological hub. This is a biomass power plant project, basically, for the production of onshore and offshore green hydrogen and storage systems. As I mentioned before, we are part of the EPH group based in Prague, one of the largest electricity producers in Europe, with business activities in the Czech Republic, Slovakia, Germany, the Netherlands, the United Kingdom, Ireland, France, Switzerland, and Italy. Now, let me switch to something more interesting now, which is our network architecture. In the last few years, we tried standardizing everything regarding our plants. So you can see here our standard for plants. Basically, our control network, process network, database servers, central PI servers, and PI Vision web servers. So it's basically a chain that makes everything available in the corporate network. We have a network that acquires data from several plants and centralizes data. So basically, we are also going to include a central server and an application server. Here we have the Seeq agent that sends data to the cloud. So that's basically our architecture, our network and data integration. Now this is simplified into blocks, but it's the same thing I showed you in the previous slide. So we have the DCS power plant, we have the data archive, and central systems in the headquarters with applications and data warehouses sending data to the cloud. So basically the Seeq server. Now let's proceed with our Seeq use cases. Now, a crucial point in Seeq, other than prediction, is the use of daily operations. So even understanding predictions in cases that can really take a long time with Seeq, with other tools, improves and optimizes data understanding things faster and in a more efficient way. Now I'm going to leave the floor to my operation colleagues that might explain to you better how this works. Good morning, everyone. My name is Michele. Now we are dealing with a thermoelectrical plant, and there might be some accidents in delivering the power plant efficiency, thus implying some costs. So with Seeq, when there is an accident or an unexpected event, we try to reduce timings to the minimum. So, for example, we had a steam coil trip. This sometimes can happen, thus compromising the security of the system. We found the cause of the security valve opening to avoid it happening again. How did we do that? We prepared a worksheet with Seeq, and we imported the pipe points to the server. What's the added value? In this case, we basically changed the way we analyze the event. With Excel, organizing this analysis can be very complicated with just 2 axes, trying to size all the variables so that they match with the correct comparison. Whereas with Workbench, you're able to check the signals separately and analyze the event, thus immediately noticing, comparing the event with the other groups, what the issue was. So basically, we obtained the pressure of one of the works, which instead of decreasing and going towards the inner part of the system, started oscillating, leading to a security issue and also causing some noise. So what did we do? We started analyzing the dimensions at place, the values that they reached, and we started trying to understand at first sight what could have been gone wrong. Now this value that you see here, which corresponds to one of the valves involved, opened, which didn't open the way we expected. So basically the valve wasn't behaving the way it was supposed to. So we thought, let's compare the other 2 valves in other cases and how they behaved. So with this comparison, what seemed off to us was confirmed. The valve opened immediately instead of opening so slowly. Such an analysis could have taken days. Now, just 2 people in 10 minutes identified the exact problem for the maintenance of the plant to solve the issue. So, if that was the problem that needed to be solved, we looked at the logic and we wanted to make sure it was identical to the other groups. Now there was an error, and the block logic was modified, thus compromising the functioning of the system, of the valve. And this, of course, caused security issues. So that's the solution of the problem. Let's look at the before and after picture. Verifying the events with Seeq allowed us to see this oscillation that was quite unusual. So we saw this variation going from 4 to 13 in a pretty weird way, and this caused the opening of the security valve several times, thus damaging it and leaving it open. So from the outside there was also an issue that was visible. After the change that we made, the chart shows a decrease in pressure, but then it recovers and goes back to normal. So with Seeq, we were able to analyze the problem extremely easily and find the cause in a very short time with capsules, and that's a very important skill for the software for operation and maintenance. Thank you. Let me add something that we left out this morning. This type of analysis is very fast and quick, and it takes a very short training. A very normal user with no experience with Seeq in 1 day of training would be perfectly able to analyze these data in the assets. So that's impressive. And another strength in Seeq is prediction. So we used Seeq together with the water determination. So we tried having Seeq determining this value to see if we could find out something interesting in the tool, maybe for the future. So this is what we did. We had different membranes. We wanted to check the dirtiness of the membranes online and during washes to check their effectiveness. We had this new demi plant, and we wanted to check the membrane's effectiveness, generating a report about it. Now, the report was going to be useful both for maintenance and for operation, without having to go and check the HMI. So how did we do that with the tool? Basically, we created a template, an AF template, starting from the PyAF template. Now, generating a template means generating an object to be used as a base for building the same element or similar elements. This allows you to map all the necessary measures and use the Seeq swap function. These are static points. Having done that, we created our first analysis with the AF attributes, importing the data into the Seeq workbench, and we started doing what we wanted to do. So we took the pressure signal of the membrane and the flow and temperature signals, because the temperature impacts the diameter of the hole, changing the pressure. And of course, the flow changes the pressure as well. So with the prediction tool, we generated a signal to model. This is the flow pressure. We sent this data to the new plant. So basically, we were able to generate the functioning curve at a base temperature. And it turned out that the movements from the expected value to the real value and from the total delta P to the predicted delta P, that was very good. So as you can see, the expected/actual deviation is 0.1 or 0.01, so it's very good. And then we went on with the analysis. So we generated some capsules, which are basically events generated by certain conditions. So green capsules are the plant functioning, so the flow feed, the operation. The flow feed was more than 1 cubic meter per hour, and we removed anything that was shorter than 5 minutes. And then we have the red capsules indicating at least 1 dp our boundaries during operation. Orange capsules had an alert on the deviation between expected value and real value exceeding 1 bar. This deviation was calculated as an hourly average of the deviations in absolute value to avoid signal spikes or incorrect capsules. And then we created this purple histogram that, as you can see, shows the daily counters of orange capsules on a monthly basis, so on a daily basis but over a month, showing the overall plant situation. Now this allowed us to see. This was something that happened in July, a water anomaly. And we saw an increase in pressure. You can see it in the green membrane 1. Membrane 2 is working less, and it gets less dirty than the first one. So we saw a dP increase and 3 anomalous deviations. At that point, we saw this warning event, we interrupted everything, and we carried out some more invasive cleaning interventions. And as you can see here, at the end of the activity, we went back to a normal functioning with the initial delta P. So, right before the cleaning. So let's go back to this. Having generated a template before and analyzing all the events using the app function, basically you just duplicate this display, and using the swap function you can go back to the other asset, maintaining the whole analysis, the whole asset. You keep it all, and this allows you to have an analysis on a number of assets. And then we wanted to test the Seeq organizer as well. Now this is a pretty simple report that allows operators to see over a day which membranes are experiencing some anomalies. So it basically shows daily anomalies through a tree map view. And here you can see the monthly functioning of all 4 membranes and the weekly functioning of the different plants. This report was generated and it was implemented to be updated every day at 8 a.m. So when a person opens it in the morning, the data are updated at 8 a.m. So you can create a PDF document, of course, you can share it, etc. So what are our next developments for the implementation of this tool? We want to increase and improve data acquisition, thus exchanging and exchange data and make them as a historical infrastructure. We want to integrate the whole system. It's a very powerful tool, but when we acquired Seeq, we assessed we wanted to try part of it because we didn't have enough time and resources to dedicate to all of Seeq Data Lab. So we want to really extend to that. And users who are now using Seeq at plant level or at engineering level, as well as performance level, are going to increase, we want to really increase the number of users using Seeq. So we want to improve system and system integration, system use. We want to improve assets and equipments used through Seeq and all of these tools. And we want to increase data availability. So at network level, what we really want to do is make plant data available, not all of them, of course, but at least part of them, managed by different areas, and integrate them with several systems we have. So Seeq at asset management level, or with another tool making shift management operations. So really improving efficiency of Seeq with integration of others into other systems, increasing the assets and equipment analyzed, increasing data availability, and improving the time to value ratio. The solution is a synergy. We all know each other within the company, even in person, and it's nice to work together. Working together, we get new ideas for innovation, and we would like, within the next few months or even years, we would like to be able to make a control team, to create a control team. We already have some people doing that, but we want to make it more official, so to speak. We've been talking about AI, machine learning, so really at staff level, we could implement these technologies to create some new efficient teams. Now let's look at the results. Of course, we improved our skill set, we used data to prevent bugs and issues, and we generated added value in terms of time efficiency. So, do you have anything to add, guys? I think we've said everything, yeah? So, yeah, this morning's we've been saying so many different things, so we're done with our presentation. Thank you. If you have any questions, we're here for you to answer. They're here for you to answer, actually. Hello. Thank you. I have a question regarding your second use case. Yes. That. I was wondering, the dark curve, the second trend, this one? Yeah, the one below, yes. That was an expected value, whereas the blue line was the real value. Now, after the correction, after the cleaning, did you understand why it went below the expected value? You should ask the maintenance department. We had a very invasive cleaning. Yeah, we should ask the maintenance department, as I was saying. This is a very small detail, but really, you were very careful. Yeah, you told us to ask questions. But yeah, basically, maybe you can answer this better. Yes, the cleaning was very invasive. Thus, it might have compromised the membrane functioning. These membranes were not exactly the correct size anymore. Okay, thank you. I was just curious. So yeah, he was the right person to ask. Any other questions? You showed us interventions generated by the system. Now, we developed a tool to generate reports. Is it possible to generate automatic reports, giving the system some other data? I'm going to steal the microphone from my colleague. Yes, to answer this quickly, the answer is yes. We use these data to make vibration reports on steam coils. So we use a constant value to do that. And this constant value can have some oscillations, of course, thus increasing the K value. And we generate a report on that, and we use Organizer to do that on a weekly basis. So that's how we control that trend.
Just another mention about the automatic reporting. Can either be time-based or event-based? So, for example, you've got your weekly report, daily report, but also, like, if a failure, you have a report automatically generated of what's happening before the failure. So they can be time-based or event-based automatic report generation.
Perfetto. Grazie ancora agli amici di produzione per la presentazione.